Phew. Okay. Hey everyone, can everyone hear me? Hello, hello. We're back again for part three. Well, so for those who are new to this live stream, over the past few weeks, I've been trying to build a program that can break down a K-pop song into a piano cover. And so far, we've made something like this. So it sounds very broken so far. So let me just run this file. So basically, when I run this script, um, just take a second. Yep. So right now, it's trying to get the frequency values of a K-pop song, and the K-pop song that we're using is Jungkook's My Time, and it created a piano cover. And the end result. So hopefully, you should have my audio up. Let me just put my audio to loud. So this is what the output sounds like. Yeah, so as you can tell, the output's very broken, still not at that level yet. But we made some good progress. At least we're able to get a program that could produce something, right? So right now we're gonna have to work out the timing. Yeah. So last week we tried to find a way to group up our values. So for further context, let me just show you my planning. So this is what we did last week. So basically, um, in our song, My Time, there were around 14,000 MIDI values. And what a MIDI value is that it is a number that represents a note on the music scale. So for example, C4 will be represented as 60. A4 will be represented as 69. So these what the numbers mean. So here we have an example of a several MIDI values, as you can see in this part of the diagram, and basically we have to try find the timing between these values. So last week we calculated that one MIDI value takes around 1 point forgot where I wrote it down, but basically one MIDI value takes around 1 millisecond, and we have to try find out. Basically, this is the key bit, this bit right here. We have to try find out which values constitute a whole note, which values constitute a half note, which ones constitute a quarter note, eighth note, and so on. And so far, we've been testing several assumptions. So one of the assumptions is that most BTS songs are written in the 4/4 time signature. So let's just go back to some music theory. Do you know whenever you read a piano sheet, they have this sort of thing where you have lines, and that line is divided into like these smaller sections, and then you have the numbers 4/4. What that 4/4 represents is that for every bar, so a bar is like a particular section, for every bar, there are 4 beats per bar, and each beat is a quarter beat. So that's where the second 4 comes in. So that's what 4/4 stands for. And we've been using this information to try and work out how we're going to allocate the timing between the notes. So I know there's quite a lot to summarize because we did a lot over the past 2 weeks. Um, so yeah, hopefully I explained myself clearly. All right, so what we're trying to do here now is we're trying to, first step is to group up the consecutive the repeating values with the non-repeating values. So let me give you an example. So let's say we have, hopefully you should see my notepad. Let's say we have a list of numbers like 1, 1, 2, 3, 3, 4, 5, 7, 7. Let's say we have this list called X. We want to produce a list that looks like this. Let's say it's called Y. We want to group all the repeating numbers together. For example, 1, 1 are together. All the individual numbers by themselves, repeating numbers together, which would be 3, 3. 4 is by itself. 5 is by itself. And 7, 7 are together. So that's what we want. So this is what we have X, this is what we want Y. And the whole point of doing that is so repeating values are helpful because they could indicate repeating MIDI values could likely indicate a longer beat, for example, a whole note or a half note. While individual values could indicate like a short beat, for example, a quarter, eighth, uh, that's what eighth, etc. So that's what we're trying to do, trying to organize this data. And we spent a long time trying to get this particular solution. So trying to zoom in. How do I zoom in? There it is. Yeah. Cool. So we tried to do this sort of thing with divide note list, but this didn't work. So I'm gonna try figure out how we're gonna do this again. Um, so I'll show you what we did last week and why it doesn't work. So let me just open up the command prompt. Sure that's big enough. All right, so Python imain.py. Oh, wait, let me just cancel that. I don't want to run the whole function. So we're writing our script. We have been writing our script in Python. Yeah. So let me just get out of that. Control C. Oh, hi. Whoa, people are joining the chat. Hi, everyone. Hi. Hi. Ash asked, do you have a GitHub? I do have a GitHub, but it's only for my private projects. Yeah, I don't have a public-facing GitHub at the moment. Yeah, because most of my stuff are just private, and to be honest, they're not that great. Like my code is not the best, so. But once I get this up and running, yeah, I'll post it. But it's just very hard. This project, I don't think anyone has attempted it before. So I have like no resources to rely on. I've got no precedent to look up to. So we're just doing this all by ourselves, Well, so yeah, if anyone here is a coding genius, like Namdo-san or someone, yeah, just let me know. Yeah, I'm keen to get some help. Otherwise, just watch me struggle. Yeah. All right, so I'll give you an example of what we did so far. Let's say we have this list. All right, let me just copy and paste this. All right, so here we got this array, and we're going to call our divide note list function, blah, blah, blah. As you can see here, so focusing on the last line, this is not what we want. So we want to have our list that looks like this, but our actual output or the code I wrote so far looks very different. So here there is an extra one, the 2 is with the ones, the 3 is with the 4s, and there's an extra 3, and the 5 and 7s have been left out. So that's not what we want. So we have to try find a way to do this. So hopefully that's clear. Yeah. Hopefully you can see my problem right now. Oh, thanks, Ash. Yeah, thanks. I'm glad that you enjoy my channel. Yeah, my channel is all about K-pop and coding and maths all combined. Yeah, I don't think there are any other channels that do that so far. So I'm grateful to be like I'm on the first to do that. Yeah. Okay. So this one's trash. Let's just take that out. Let's just do this again. So I've been thinking overnight how I could do this. Alright, so let's think. Let's just go back to the drawing board. Alright, so let's just do this on this part. Oh, oh, wait, I can't shift to the. Oh, there it is. Okay, dokie. Hmm. Insert number. Okay, we have this example. How are we going to get from X to Y? So this is our goal. How do? Hmm. So Nadia asked, "Do you know other languages?" Yes, I do. So I know Python. So languages that I'm comfortable coding in are Java, Python, JavaScript slash Node.js. These are the three languages that I think I'm pretty good at. And yeah, um, these I think with these three languages you can do anything. I don't think you really need to learn any other language apart from these three languages. Yeah. Oh, Laura. Thanks, Laura. You're a junior Python developer and an army. Oh, that's cool. Nice. Welcome to the Techie fam. And thanks, Trinity. I'm glad that you guys like my channel. Yeah. So the whole point of this live stream is to show you like the true behind the scenes of how I build my projects. It's nothing too fancy, nothing too big brain genius. Just me, just trying to like figure my way out how I'm gonna build this stuff. So yeah, that's hopefully I can and inspire some of you people to build your own projects. Yeah. Welcome back, LTEB. Okay, let's just figure how we're gonna do this. All right, so we need to create a. So we need to have some variables. We need to recreate our list, and that list. Let's call this list. Let's call this list our process list. So this list is. So Y is our process list. So that's our Y. Okay. We need to do that, and we need to create um a temporary list for. So we're going to, you know how list Y has smaller lists. So let's call this actually let's call this our micro list. Micro list. This will contain those values, and let's just call this ML. Actually, let's just call it micro list. Keep it like that. And we need to make sure how we're going to keep track of repeating values. So we should have a last seen variable that keeps track of previous value. So that's what we're going to do. Okay. Basically, so we're going to loop through, we're going to um, loop through the list, and um, if current value is equal to last seen, then we're going to uh, where's my oh, then we're going to um, add current value. I'm going to call it CV. Add current value to microlist, and we're going to update last seen. Yeah. Oh, wait, do we need to update last seen? Uh, hmm. I don't think we need to update last seen yet. Okay. else, okay, else if the current value is not the same as the last seen value, what happens? Hmm. All right, let's just say we let's start at 1. Okay, let's go back to our. All right, we start at 1. Last seen, so last seen equals 1. And so automatically then start at this one. So does 1 equal 1? Yes, it does. So micro list is gonna have 1, 1 in there. And then we move to 2. Does 2 equals 1? No, it doesn't. So when it doesn't, we're gonna have to close this micro list. So we're gonna close it. So that's where we are closed. So here we're going to close the micro by adding micro to process list. So process list y. So when we close it, y is going to have this part added to it. Yeah, that's going to be added. And then we're still at 2. So when we're at 2, we have to empty the micro then. All right, so we're going to have to empty the micro. So we need to empty the micro. Actually, we don't even need to empty it. Micro just gets updated to the current value, which is 2. Because once we're at the current value, because 2 is the current value, that means ML, will be updated to 2. Yeah. And then last scene we updated to 2. Okay, so now we move on to 3. Is 3 the same as 2? No, it doesn't. So if it doesn't, then we close the micro. That's right, add it to that. And then micro gets updated to 3. So that will become a 3. And that would be a 3. Okay, now we move on to that. Does 3 equals 3? Yes, that does. So here, 3 gets then added to that micro list, and we just continue. Then we go to 4. Does 4 equal to last scene? No, it doesn't. We close the 3 micro list, add that to what? Oh, cool, we got it. All right, I think that's it. Oh yeah, update. We also have to update the last scene. So then we have to update last scene. All right, so that's our pseudocode. So when I say pseudocode, this is what I mean. Pseudocode. Pseudocode is basically how programmers plan their code. It's basically writing code in English, and then you write out the full code. Hi, for those who are joining, hi, Valencia. Hopefully, I pronounced your name correctly. Yeah. Laura asked, "Is X always sorted?" No, it's not. No. So what I just did here was a simple example. Um, I should show you what it actually looks like from. Actually, I'll show you a bit later what the values actually look like. It's all like a bunch of random MIDI values, so they're not sorted. Now, we can't rely on a sorted assumption. Ash asks, what are these X values representing? The X values represent the MIDI values. So MIDI is MIDI. MIDI values they are integers that represent a note on the music scale. So for example, C4 is represented by 60. A4, if I recall correctly, is represented by 69. So you have all these whole numbers that represent a piano. That's how the computer was able to produce that piano track in the first place. E. Mm. Okay. Okay. So let's just put this to the side. Um, okay. This one should be simple. Okay, so we're gonna have to recreate a list. So let's say process list is an empty list. I have a micro list. So is the microlist empty or not? Yeah, it should be empty. And we need to create a last scene, and the last scene should always be the first value of our list. Okay, should be it. Yep. Okay, and then so for n in note list, if n is equivalent to last scene, then we're going to add c as that to the micro. So micro list dot append n. Else process list append micro list. And micro list is updated to the current value, and the last scene takes on the current value. Let's try that. This may work or may not work. Oh, Chris, what up, Chris? Yo, thanks for joining. Okay, let's go. Oh, for those who are Python developers, do you know how sometimes if you only want to test one function without having to run everything else, you can just do Python -i. I means interactive mode, and just type in the name of your file, and it goes into like the shell interactive mode. So that's kind of cool. Divine this hopefully has this installed in memory. Okay, let's try that. All right, that's right. 2, that's right. 3, 3, 4. Oh, it doesn't. Why 7? This is probably an edge case. All right, so what I just said was something called an edge case. An edge case is like basically describes how do I explain it? Basically, if the algorithm doesn't cover everything, and the thing that it doesn't cover is called an edge case. So that's what an edge case is. Welcome back, Andrea. Yeah, this is part 3. Yeah, if I don't complete this project by part 3, then oh man, I suck. Okay. Why is 7 not covered? We're kind of close. Why is 7 not covered? Let's go back to this. All right, we'll move on to 5. We'll move on to 5. So last thing is 4. Does 5 equal 4? No, we add that. And let's say we're going to 5. Okay. Does 7 equal 5? No, it doesn't. So we're going to add in 5 and last scene. So at this stage, once we get to this number, at that point, last scene is 5. ML has a 7 inside. Okay. And then that will be updated to 7. So we get to last value. Does 7 equal 7? Yes, it does. So we're going to do it here. Oh, okay. I see the problem now. It's okay. So the reason why 7 this because this this part is only is comes from this part, right? And there was never an update to the process list. Okay, so we're gonna have to do that manually, which is simple. I mean that's simple. All we can say is if the length, so after we finish the loop, so once we've gone through the whole list, if the length of microlist is more than 0, which means that there are, we call this leftover numbers, leftover values, edge case. If the microlist is still not empty, then we just simply add that to the microlist. That should be it. Let's try that. Ash asked, is it like switch cases in Java? Well, so a switch case is basically a very technique. I don't think Python has a switch. I don't think Python has switch cases. So Python is just mainly just if else, yeah. Okay, let's try that. Oh, all right, that's pretty good. That's pretty good. That's pretty good. All right. All right. We got it, boys and girls and everyone. Yeah. All right. That's what I wanted. So this can die. Oh my gosh. Oh, this feels so good. All right. So what was the whole point of doing that? The whole point of doing that is so that we can then probably work out the timing of the notes. So I'll just print out what the numbers look like so far. So let me just call this value. Um, just this way. Yeah, that's probably in the yin algorithm. Length of MIDI. All right, pre-MIDI should be here. Okay. All right. So as you can see, everyone. So if you look at all these numbers, this is what I mean by MIDI values. There are around 14,000 of them in this Jungkook My Time track, and each of these values represent a frequency. Oh, so these values came frequency. So what the algorithm did was that identified the frequency at each point of the song, and then there was a formula for converting frequency to MIDI value, which is what we did in part 1, and it created this whole list of numbers. But the thing is, these numbers don't tell us the timing. That's why we try to create that list of repeating values and non-repeating values. Because you can see here, like if I highlight this part, there are repeating 55s, and that could suggest that that is a note. Yeah, does that make sense? So because we could play every single MIDI value as a note, but then the piece would sound really, really random. So I can give you an example right now. Hmm. So this is what it sounds like if we use every piece. Hmm. Right, right. So you can see here it's 2:41 my time and 2:41 right now. So this is what it sounds like when all notes have to play. as you can hear, it's very random. It'll sound very random if we play every single note as a list. So for example, these 55s, there could be two semitones or one whole note. Who knows? So we have to try to work that out. So that's the whole challenge for today, to work out which values are actually one whole note or individual notes. Yeah. Ash suggested nx.count for x in set is a way to do that method using list comprehension. Ooh. Okay. X.count. So count is x counting the number of values in that list. Okay. For x or usually or sets. Okay. Yeah. I'm not that. I'm not too familiar with sets in Python. But yeah. Oh, thank you. Thank you for that. Thank you for suggesting that. Thank you. Yeah. Okay. Cool. Good to know. I think I'll stick with this for now because it's easy to explain. And if we need the debug, we can just accord it. But yeah, thank you. Okay, so yeah, there's a bunch of like notes I just have in here. Yeah, so for those who are just watching this for the first time, I don't think this might not make any sense because we've been building the work that we did in part one and two. So I guess I'll just do my best to recap everything. Um, Man, this is what happens when you program, right? Like you spend so much time writing the program, and then you leave it for 1 week or even just a few hours, and then you look at it, you just don't know what's going on. It's so crazy. I basically have to relearn what I did last time as well. So I guess this is what we have here, just relying on my notes from last week, from 2 weeks ago. Sorry, bless me. Hopefully I didn't jump scare anyone. All right, so when I Google searched Jungkook My Time, that song is 100 beats per minute. 100 beats per minute, which means there are 100 divided by 60 beats per second. And we know that there are 14,653 millibeats in that song. If we divide it by 390, 390 is the number of beats in total, that gives us around 36 values per beat. So there are around 36 values per beat. And 36, because remember our time signature is 4/4, that means there are around 144 MIDI values per bar. So if I go back to the code here, if I highlight, let's say 144 numbers, these 144 numbers represent 1 bar of the score sheet, right? So in that 1 bar, I'm not sure if there are 144 here I've highlighted, but just assume that there are 144 of them. We have to work out which of these are. We have to work out what's the actual what particular beats have been used. So in the 4/4 time signature, you can have one whole note, or you can have two half notes, or four quarter notes. So we have to work that out. That's why repeating values are helpful because we could probably deduct that, let's say these 53 numbers are actually one quarter note. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe. I'm not sure. Let's just figure this out. So we're gonna have to figure it out. We're gonna have to keep track. I'm just gonna keep a note of this. We're gonna have to a counter that keeps track of beat values. For example, if we used up a quarter note, that means we have 3 quarters left to use. If we use up a half note, that means we have half left to fill in for that for the bar. Yeah. Mm. And then once we identify that timing, then we can then input in the duration. So by our calculations, where's my thing? According to our calculations, 1 MIDI value is around, or 1 beat is around 1.67 seconds. Yeah, so we can use that to work out how long we're gonna specify our thing. Yeah, yeah, guys, it's really hard. This is really hard. It's so hard. I might go crazy in the next hour. So yeah, I might go crazy. So enjoy it while I'm still sane. Yeah. Yeah. So yeah, let me like everyone. Let me know which country, where you all come from. Like, so I'm in Sydney, Australia. Yeah. Just write it in the chat. Where you guys come from. I like to know where my audience comes from. Yeah. Okay. So last time I specified a start and end, so that works. So we need to divide our list into smaller components. Okay. So let's take an example here. Let's say this is our list. This line represents our list. We need to divide that list into the bars, right? And each bar has 144 values. Yeah. So each bar is 144 values. Oh, oh snap. 144, etc. So in programming, numbers start from 0. So this is position 0 or index 0, and this will be index 143. And 0 will be our start index, while 143 will be our end index. And to get to the next bar, start index will be updated. Update start index to 143. That's how we get the new start index. And then we're going to update. We're going to increment end index by 144 to get to that bit. So 143 plus 144 is 187. So that's our new end index. So we're gonna do that on a rolling basis. All right, so England, oh Jamaica, okay, Colombia, US. Oh, I have an international audience. Oh, Techie Ray going international. Oh yes. Oh, I feel good. I feel good. Oh wow. Hmm, cool. Oh, that's awesome. That's awesome. The techie fam is big. The techie fam is big. Okay, if I have enough clout, if I have enough people watching, I might be able to meet Dreamcatcher. Oh yeah. I have this huge fantasy, right? Just I don't know, just being like a software engineer at actually I just a quick take there's this meme, right? Is it called cheerleaders for programmers? There was this meme, right? Where is it? Let me just see it. Oh, this meme. Oh man. Okay, so basically, tech companies in China are hiring programming cheerleaders, girls that cheer up programmers as they work. It's weird. It's so weird, but that's my low-key fantasy. Like I'm just like one of them working as a developer in a K-pop company. I don't know, just building. I don't know, just I don't know what stuff they build at K-pop companies. They even need software engineers at all. But like, just Dreamcatcher just massaging me. Oh, a guy could dream. Yeah. Maybe SM, right? Because the new girl group, aespa, Espa is all about AI, right? They probably need software engineers, so I'll just join SM, and then like there'll be SNSD, Red Velvet, Espa. Okay, I'm getting off track. I'm getting off track. So let's continue this. So why MIDI value is less than the length of MIDI list? So that way we don't encounter into infinite loops. Oh, and make sure we encounter infinite loops. Let's just do this first. So we're going to increment this by 100 millivalues per bar. And we're going to, oh, yep, Dreamcatcher bias, yep, unite. Oh, bro, yesterday, okay, so my other favorite girl group is CLC. And yesterday, Dreamcatcher Sua and CLC Sunyeon, they did a collaboration. Oh my god, it was so good. Oh, my heart, it was, oh my gosh. If you guys haven't watched that, oh my gosh. Oh, when you have two main dancers of my two favorite girl groups just dishing out the moves, oh my gosh. They were good. It was good. It was too good. Yeah. What am I talking about? Alright, so start MIDI value adopts the end MIDI value. Okay, and so we're going to then process lists. Actually, yeah, let's call this process list. Process list equals, because we're returning a process list from this function, right? So we're gonna call this function. We're gonna call it here, and so MIDI list has the entire list. So we're gonna break this up into 144 segments. So it will be start list, start MIDI to end MIDI. So what I just did there was basically this. So if I just clear this. So if I just go into Python, I just do x equals 1, 2, 3, 4, 5. If I do x0, that'll give me, oh, wrong command. Oh, I have to do this again. Typo. Wait. If x equals, if x index 0, that'll give me 1 because that's the first element. If I do x 5, that'll give me 6. If I do x0 to 2, that means I'll get the values between the first position and the third position. Remember, indexes count from 0. That'll give me 1 and 2. So that's what I'm doing here. I'm getting 0 and I'm getting 144, which means I'll get wait, let me make sure this actually works. I'm gonna get 144 values. So I got two values. So yeah, this should give me 144 values, and that's our bar. Remember, 144 is a magic number that gives us our bar. Yeah. So Adrian said, I never listened to CLC any Sonic. Oh, bro, I can preach the CLC Bible to you. Oh my god. Oh, CLC. Okay. Oh, there's so many. Oh, there's so much gold in CLC. Okay. You should listen first to No. It's literally called No. Yeah, CLC No. It's so sassy. Yeah. Black dress. Yeah, Matt suggested black dress. Black dress. It's so good, dude. CLC is like, I feel like amongst all the girl groups that do like the girl crush, the badass girl concepts, I think CLC like one of the top. They definitely slay. They're pure slay. Yeah. For me, I'm not really into the cute concept. I'm not into like I don't know. I can't really watch that, but I'm into like the badass concept. Yeah. Yeah. All right. All right. So we have the precedents ready. Okay. Okay. So let's say we have our 144 values. So let's say we have like 1, 2, 3, 3, 5, all the way up to n, and length of that is 144. And then we then eventually divide it into 1, 2, 3. Okay, my phone turned off. Yes, please watch CLC. Oh, EXI, oh, exit, yo, back in the good old days. Yeah, I know what you're talking about, Ash. That's, oh, yeah. Oh my gosh. Um, okay. Oh, so the length won't be 144. Like, length will be the based on how many groups there are, so it will be a different, but we can consider that later. Okay. We have to keep track of the beats. All right, so we should give like a timer. So, uh, hmm, I'm gonna do this. We should set a threshold. Our threshold is 36. Why? Because 36 represents a quarter note. Because if you divide, because remember, 144 is 1 by 4 time signature. That means one beat, one value. So our threshold is 36. Okay. So, 36. All right. So for for each micro group or micro list in the process list, we need to get the length of micro list, and we need to increment. So we have a counter. So we have a counter equals 0. We're going to increment counter by length of micro list. So that of like space. That'll keep track of how many counts we have left in our bar. So how exactly do we do this? How do we do this? Hmm, this is tough. Okay, so let's say before we even do that, before we go into process list, we just check. Check if all values in the 144 list are the same. If so, then that's a whole note. So that would be like list dot count of list first value, if that is equal to the length of the list. If that's true, then that means that's a whole node. Yeah. That's a whole node. Okay, so we got that. And should we then? Hmm. Maybe we should have a list. We should contain a list of beats. So we should have a beat MIDI values per beat. It should be like 144. 144 divided by 2 is 72. 36. 36 divided by 4 is 9. And oh, it's not a raw, it's not a whole number. We'll just do 4. Okay, and we're gonna do. We're gonna. Do we need to use recursion? I think we'll use recursion. And we're gonna have a recursive function. Basically, recursive function takes in the 144 bar list. We're just gonna take in a bar. Actually, let's rename this to bar list. That sounds better. Bar list. Okay. In our bar list, if bar list dot count. Oh wait. For x in MIDI values per beat, if bar list, so it'll be 0 to x. So remember, when we first go through this list, x will be 144. So it'll be 0 to 144. That will be the whole list. Let's just make some functions. So bar list 0 to 144 equals whole note or whole bar. Bar list 0 to 72 and 73 to 144. That's half bars. Bar list 0 to 36, 37 to plus 36 is 73. Is that 30? Yeah, 73. And you do that for 2 more times. That's our quarter bars. So we have to do that. So if so need to divide by, so we need to get if no, we need to determine how many sections there are. So sections equals bar list, the length of bar list divided by x. Welcome back, JST NF part 3. Yeah. Yeah, guys. Then I didn't expect myself to finish this in part three. Like this is mainly just a project that will keep me occupied while I make my main videos. Yeah, so I'm making a next video, but I like to do this sort of stuff in the meantime, just to like do something different. Yeah, and I guess some of you guys like watching me just code stuff in real time. Yeah. All right, so number of section is that. So if it's 144, there'll only be one section. If it's 32, there'll be two sections. Okay, that'll be good. So sections. Okay. And sections, um, and it'll be 4s in range sections. So we're gonna determine how many sections we need. So that's that bit. So we have that. And we need to get a start index equals 0, and end index equals x. Yeah, because x would be that. So for s in range sections, so for every section, bar value will be start index and end index. Actually, just make this simpler. Uh, bar section. Okay, maybe we should call this number of sections. Number of sections equals that, and for this and that, section equals bar list start index to end index. Yeah, that's what we want. And if section dot count, geez, if the first value, if if the number, if the first value of section, if the number of occurrences is equivalent to the length of the section, then we know these are all repeating values. Then what? What do we do? How do we do this? Okay, if the number of first values repeat in the section, then that means we have a true, that means we have a note. Let's call this number, let's call this a neat note. We have a neat note. So we should have like a counter or some flag. Hey, Cookie Monster, welcome back. Hmm. If section count equals length of section, then we have a neat note. Then what does that do? Maybe we should have a neat note list. Neat note. Then it will be neat note append section 0. Alright, we have that. Then what? Then what do we do? We append that and also hope of doing that. Okay. Then so this will check every instance. So this will check everything. Actually, we don't need to check every case. We only need to check if it doesn't. Because this will be like, using for loops will take up like, oh, like, this will be like very inefficient, right? So we're gonna try reduce the work the computer has to do. So if it doesn't mean that, then we just break. We don't need to continue checking every single, we don't need to check that section again because we're not interested in that. We just need to make sure, we just want to do a preliminary check if the bar itself is clean. And we just need to say like print, let's say just say print not clean bar or not consistent bar or not consistent section. Let's try that. And we're gonna name our function later, but let's just have this up here. Let's just call these our helper functions. Let's just create our helper functions, and we're gonna this doesn't stand out. Let's make it stand out even more. Helper functions. And this is our main function. Main function. Okay. All right. So we're not. This is not a recursive function. We don't need recursion. Let's call this a prelim check, or we can call this check bar consistency. And the whole point of doing this, we need to get a def for. This function checks if the if checks for every instance, checks for every possible. I don't know how to word this. This is one of the hardest things of code, especially when you need to write documentation. You have to try explain in English what your code does. And sometimes it's just so your code does something so specific that it takes a long time to describe in words what it actually does. So, but I want to make sure I remember what I did, so I have to write my notes carefully. So this function checks for every section in the bar, and checks if, and for each section checks if the MIDI values are repeated. If so, then depending on the length of the section, that may indicate a beat. And I should just do it. I should just do this up here. For example, whole bar. Yep. This is what I mean by just I'm just putting your notes down. Just remember stuff. Yeah, etc. Okay. So we don't need to check every section. We just need to know if there are any clean sections in the bar, which may allow for shortcuts. Otherwise, return false. Hmm. Need node for x in MIDI values. Number sections there. MIDI values would be no, we have a bar list. So we need to copy this part in. I forgot MIDI values would be. Is that a scoping? Is that a did I used that term before? Oh, whatever. I'll just do MIDI values per section. It's much easier. Okay, so for x in MIDI value, will this code be published on GitHub or somewhere? Yeah, once I finish it, which may take a long time, but yeah, I'll want to publish this if I'm able to put it off, pull it off. Yeah, it would be so cool, right? If this could actually work. Like the whole K-pop piano cover community would just get wrecked. It would just get wrecked because this is programmed. They can just generate these piano covers in less than 1 second. And then my channel will probably become a piano cover channel. Just dishing out K-pop piano covers. Oh my gosh, imagine that. Imagine the potential. Wow. Yeah, they get wrecked, like destroyed. The whole K-pop piano cover YouTube community. Yeah. Uh, just for fun. Just for fun. Maybe we should call this number of values per section. Number of values per section. Okay, number of sections, length of bar list divided by x. Yeah. Um. Yep. Or s in range, number of sections, section. Yep. We don't really care about this. We just use underscore. So, break. Um, okay. If a section is not clean, then we just break it. What if it does work? What if it does work? And what do we return? Break. I want to be able to return. If it's that, then we break the section, and if one section, oh no, it doesn't. Let's just keep track of the sections then. So if it does equal that, I have to draw this out. Okay. Let's say that one doesn't work, but that works. That one doesn't work, and that one doesn't work. Do I need to care about this one? And let's just say, we have this and half. That one doesn't work, and that one doesn't work. Is it still worth pursuing every section? I don't think it's worth. I think we need to though. No, it has to be all clean. It has to be all clean. Yeah. So if they're not all clean. Oh wait, you could have a combination though. You could have a combination. You could have something like this. That's something like this, and then you have that and that, and then this could work, that could work, and that could work. So this is a half note. A half note combined with a quarter note and a quarter note. Oh, this is getting big brained. Oh man. Oh, how about consistent equals not any e? Whoa, whoa. So it stops going through the list if there is an inconsistent section. Very good point. Thank you, everybody, Moo Party. I like your username. But now, okay, so now I realize it might be still be helpful to find and it might still be worth going through every section because, for example, let's just say um, this was actually a tick as well. So if we found the first section was inconsistent, that and if we tell the computer to stop looking through the rest of the list, we then miss out on these two, right? And it's very possible that they might be combined with a different section configuration. Oh man, there's so much stuff to account for. But good point. I'll copy down what you wrote here in case we need to use it. Was not. Oh, wait, wait, wait. If all the values in 144 are not consistent, do we still need to check the small ones? The small ones are just derived from the big one. Welcome to the live stream, Plasma Kitten. Plasma Kitten. That's a funny username. Alright. I'm up to my second water bottle. Cheers, everyone. Ooh. You know what? Let's just print this. I doubt they'll even have a particular section. That works. Alright, let's just try this. Print piano cover. Yeah, we got that. Hmm. Um. Actually, let's just let's just get some sample values. Oh, line 17. Oh, I used too many of these. Line 17. Line 53. Man, Python is so sensitive. The one thing I don't like about Python is that because it doesn't use those curly braces and semicolons, your space matters. Like it's so sensitive that it tells the difference between spaces and tabs. That's like so crazy. So look. I swear, inconsistent use of tabs and spaces in indentation. Python is so uptight with that. It annoys me. Like you have to highlight. Like lucky Visual Studio Code allows for this. You can see which lines are spaces, which lines are tabs. So this one is space. I gotta use tabs for that. Oh wait, no, I can't just. Oh, it's so annoying. Like I don't know how to fix these tab spaces without having to rewrite the whole line. So annoying. Oh my gosh, no, something to do with this. Oh, I actually don't need this anymore, to be honest. I don't need this. Just unbind your spacebar. Oh, is that the oh I don't. What does that mean? What does unbinding my spacebar mean? Like is that like a keyboard shortcut or a VSC shortcut? I'm not that. I'm a very slow typer, so maybe I'm not that too aware of bindings. Oh, this is so annoying. What? Guys, how do I how do I get rid of this thing? How? Is it a I don't know why. Like why is this wait oh my goodness, this is getting worse. Oh GG you. Alright, cool. Oh no, it does that thing again. No, it does that. Oh oh stuff. I'm just gonna rewrite this whole thing. Oh my god, it's so annoying. Python is so annoying. Oh my. Sorry, God. I just don't know how to like fix the spaces and tabs or having to rip the whole thing. So annoying. This is what happens when you copy and paste code, right? Wait, if I copy and paste this, does that fix this? What the heck? Alright, let me just try this method. Let me just control C this whole bit. Control paste it in Notepad. Then control C again. Oh wait, I think it's got to do with this sort of thing. Copy it across Notepad. Let me just try this. Oh my. This is why Java is my favorite. Because Java is a good boy, yeah? Python is like that one, I don't know, that cool kid who is cool. They do a lot of cool stuff, but this is their weakness, their Achilles heel. Yeah. While Java is like that nice, cool kid, or good kid, which doesn't get a lot of attention, but they never fail you, you know? Unlike here, look how much time I wasted. Look how much data I wasted. Ay, yo, yo. Oh, beautiful. All right, cool, cool. All right, you guys can go away. All right. Oh my. Oh, unsuspected indents. Oh, right. It's supposed to be. Right. Oh, God bless. All right, cool. Right, that's because I have the file open. That's because I have this open. All right, let's try this again. Python is the kid that will make friends with you when no one else will. Yeah, true. What are your guys' thoughts on JavaScript? If if JavaScript was like a character in a school, what would their personality be? The cool kid that does everything, but they have one huge weakness. Java being like the safe, nice kid that never goes wrong, but they never attract that much attention. JavaScript, I feel like JavaScript is one of those very smart, creative kids who are also low-key weird. they're like they're really into weird stuff, but they're also really smart and creative. That's why I think JavaScript. Because JavaScript, right? JavaScript's got this really weird notation. Like instead of like you can do like function X and like do that. But they also have this arrow function which is very weird. It's like this and like arrows and that. It's just so weird. I just find that so odd looking. So I feel like JavaScript is one of those weird those weird cool kids. Yeah. And then you have like C++. C++ is like the fastest kid in class. Like he always gets his homework done really quickly, fastest runner, fast in everything, but they overthink everything. On overthink? Yeah, they overthink everything because they're very particular to attention to detail. Yeah. And then C++, there they have like a brother called C or a sister called C, and C is like super pedantic. They're like, you do something wrong, they'll nag at you because you have to like specify memory, specify all that stuff. So yeah, that'll be that'll be that. Oh, Jason, what up, Jason? Thanks for joining. See, that's right. Yeah, C++ has ADHD. I shouldn't laugh at that, but yeah, C++ would be the kid who has ADHD. Yeah. Oh, it's cool that you guys get my coding jokes. That's cool. All right, let's run this. Okay, let's just grab some values. Let's just grab this whole bunch. Okay. How many values are there in X? 381. Okay. Um, 381. So let's just do y equals len x0 to 144. All right, so we've got y. And now let's just test this with check bar consistency. What does that give us? Oh no, we have to go into interactive shell. Wait, are we in the shell? No, we're not. I'll have to do this again. Soz doesn't work. Python should disable this. Python I main dot py. Okay, have we got this yet? We got that. Y. Okay. Check bar consistency Y. Float object cannot be interpreted as an integer. Oh, that's because the number of sections is not clean. All right, I get it. Hmm. All right, that's because 144 is not visible by 4 at all. Just take this away then. All right, let's do this again. Uh, that's weird. That's 144. Hmm. Do you think this software will be effective for music generally, or is it specifically intended for K? No, this could be applied to any music. Damn, that makes this program even more powerful. You can like I would like to call this the piano translator, or the song to piano translator. You can translate any song. Yeah, but it's very, I don't know. I'm not sure if it's even possible. But we'll see. We'll see. Probably missing int function somewhere. And I don't think I need an int function because it should work out cleanly. Number of sections, length of bar lists divided by x. That's so weird. Why is this, what's the length of y? 144. Yeah, why doesn't that work? Number of sections, len of y divided by 72. That should work. Oh, right, that's true. Okay, good point. Yep, that should work. It's a float. Okay, that's another thing about Python, right? Because Python is interpreter language, it simplifies a lot of things, which is great. But the one thing that's not that great is it's not strongly typed or strictly typed. Unlike Java, the nice safe guy, you have to specify if it's an integer, a double, or whatever, and you can never go wrong with this sort of stuff. But for Python, it assumes everything for you. That's also the thing with JavaScript. JavaScript also has that same attribute where it just assumes what data type you're using. But sometimes you want to make sure everything's consistent. Yeah. I mean, I should make a video on like the languages as like characters in the school. That'd be funny. And it doesn't return anything. Oh, that's because it never. That's right. That's because it never encountered any consistent values. I guess that works. And that was pretty quick. That didn't take a long time. I think we can do this. Hmm. Speed medal. Okay. Push the limits. Uh, I'm gonna go take a quick break. So I'll be back in like shortly. So I'll just take a quick break for now. It'll be like 1 or 2 minutes. I'll play some copyright-free music. Yeah. Copyright free music. Oh, where's my music folder? Yeah. Do I have any copyright free music? No, I don't. Um, oh, I'm just gonna have to stare at my screen. I'll be back real soon. All right, I'm back. I'm back. It's getting hot. This stuff is getting spicy. So yeah. All right, so that function works pretty well. Instead of print the section, let's just do an input. So the input would then it would then stop our code and see if it actually goes through the whole thing. So let's do that, and let's call this bit in our main part. So yeah, we should do it here. That works. Yep. And then process this, blah blah blah. Yeah, that should work. Okay. And we run piano cover. Alright, let's just see if our MIDI values of Jungkook My Time actually produces any consistent sections. If not, then good to know. If it does, then we might figure out a way to create some shortcuts. Let's go. Oh, so we did identify a section that has that. Oh, I forgot to specify what to continue. All right, let's just instead of doing that, instead of input, let's just do print sound consistent section, and we should specify how many counts there are at um stream dot how many we should get the section number, the number of sections x. We should get x. X tells us how big that section is. Okay, so we look at the list. There are a bunch of nines, so nines are pretty common. Okay, so nines are our quarter beats, but it aren't enough whole beat semitones. Okay, that's not good. Mm, alright, good to know. Good to know. Let's just move on. I don't think we've found anything useful with this function, but I'll just have it there just in case. Alright, so let's just go back to our original plan. Alright, so got this. So this will just check. any right, and here we just do divide the bar into groups of repeating and non-repeating values. All right, that's towards the end. Um, update indexes to avoid the devastating infinite loop. Oh, that's so scary. I'm so scared of infinite loops. It just causes the thing to say not responding and you just die. Yeah. All right. Welcome back, Anderson. Yep. I've kept the yeet from last time. Okay. For micro group. Let's use the shorter hand. Let's just say MG stands for micro group. Actually, let's print out the processes. I want to see what the processes looks like. Let's print this out first. Oh, that looks pretty nice. Oh, look at that data. All right, so looks very nice. We got some consistent values. Mm-hmm. Mm-hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 50s. Hmm. All right, so it's just a matter of then determining the duration based on these values. All right, so how do we do that? Okay, so for MG and process lists, we have to first find out if length of MG is greater than 1. Because if it's only 1, then that means that's just the individual value. So I have to find if it's more than 1. So if it's more than 1, that suggests they are repeating. Case 1, repeating MIDI values. Okay. If that's true, then we need to find out the duration. So how long is each beat again? Each MIDI value again? So, I think I had this before in my code. Specified MIDI values per beat, MIDI duration of 1 MIDI. That's right. Duration of 1 MIDI is that. So we just do duration of 1. So if length is greater than 1, then we just do duration of 1 MIDI times by length of MG. Yeah. And we have to add this to the track. Alright, so this would just do that. Copy this. Okay. So we say duration is that. MIDI time. Oh no, what did I do? Okay, cool. Okay, so duration is that MIDI add note time. So I need a so time is 0. That's right. Duration is just a local scope. Don't want to make any more scoping errors. That's last in part 1. I wasted like half an hour just trying to work out the scoping error. Time is added by duration. So this is a global time. This time accounts for the whole track. So that's what we do. We update this by duration. And oh, we don't even need to check if this is 1. Because we're doing the same thing for just the 1 case off. Actually, don't even need to do that. We'll just do this. And then the MIDI would just be MG the first value of that list. It doesn't matter if it's a repeating case or a non-repeating case. The first value of that micro list will always be the pitch value that you want to play. And duration would then just work out based on length. If it's only 1 value, then it just be 1 times duration. Okay, let's just see what does that sound like. That was simpler than I thought. Do I have to add in? No. Okay, let's try this. Alright, successfully create a piano cover. Let's go back to our folder. 354, yep, 46 KB. Let's listen to it. Alright, this sounds broken. Still sounds broken. I want to delete all this stuff. This stuff is so distracting. This stuff, just delete it. Keep that. Alright. Duration of 1 minute is duration divided by. Let's do that. What's that again? So the 234 seconds, 0.5 divided by 14653. 0.016 times 1,000. So it's 16 milliseconds. 16 milliseconds. Okay. So I should write that down. 1 MIDI is 16 milliseconds. What if we just increase that to 1 second? Like maybe the pattern's correct, just the duration's wrong. Actually, yeah, let's try that. So instead of just duration times that, we'll just do duration equals 0.5. Let's do 0.5 times G. Let's try that. We're just playing around with all the sounds. Timing. Alright. this sounds pretty legit. This sounds pretty legit. Can you guys hear it? No, that was short. Oh, that's okay. Okay, let's make it faster. Next, I'm not sure if you guys heard that. Just let me know in the comments if you couldn't hear that sample. Just save this time. Even if this is not an actual K-pop song, a computer still made a freaking piano melody, right? So I could actually I could be sneaky. I could be very sneaky and just rename all three live streams into saying writing a program that creates piano songs. I could just rename it like that, and I could end the live stream. So I could just pump out all this random. Anyway, let's just continue to test this. Let's check it at duration equals 0.25 default case. Yeah, this live stream will stay up. Yep, that's right, Brooklyn. Thank you, Ginny. Moz. Okay. All right, maybe okay, let's try a different sample. Actually, maybe it's got to do with how I don't want to open the file because last time I got copyright strike and the whole thing got muted. So um actually okay, in order to be safe, I'm gonna turn off desktop audio so that you guys can't so if you guys can't hear the audio, then the video won't pick up the audio, which means I won't get copyright strike. But if I then turn my speaker to my headset, I can hear it, you can't hear it, we're all good. Okay, that's good. So let's try that. So I'm gonna try edit. Let me edit this file. So let me just get the chorus and then we're gonna convert the chorus to a cappella version. So guys, I'm gonna teach you how to create a MR removed video. I'm gonna teach you how to create an MR removed video. So I'm just gonna drag and drop. I find Windows Movie Maker just easy to just do this stuff. Yeah, you guys can roast me if I still use. You guys can roast me, I don't care. Actually, let's make this accurate. 234.5. Make sure you guys can't hear it. Alright, I'm gonna play a little bit. Can you guys confirm they can't hear this track? Alright, let me know if you couldn't if you couldn't hear what I just played. You're not supposed to hear it, okay? You're not supposed to hear what I just played because YouTube strike me. Yeah. I'm just going. So Brooklyn asked, how do you come up with this stuff like this? Was there base code out there? Oh no, this is part three of a live stream, so I've been building this. Well, um, the the yin algorithm, I already had this on my file. So if you look at my channel, I made a video about my karaoke app, my karaoke singing app. I used the yin algorithm to help detect the picture. So this was like the only file that I could leverage off, but the rest we had to come up ourselves. So yeah. All right, good. You couldn't hear anything. That's perfect. That's perfect. I won't get copyright strike. Woo! So I'm gonna edit this file to the chorus. Okay, let me just cut that bit. All right. All right, that off. I'm just playing just for the chorus, and that's around 20.7 seconds. All right, file, save audio only. Desktop. All right, this is called my time chorus only. All right. Okay, close. Yeah, whatever. No. All right. So I'm gonna also, guys, teach you how to convert MP M4A files into WAV. So just do ffmpeg -i my time chorus dot m4a into my time chorus dot wav. Boom. See that? That's done. And now we have a WAV file. And now I'm going to convert this. I'm going to get the acapella version. So I have a library. So, um, where is it? Where is it? Where is it? Can't find it. Is it AI music? Yeah, AI music. Do that. I have to switch folders. Actually, can I just do this? Control C. Switch folders. Okay. I'm just gonna have to just type in one of these commands. I forgot the command, so I'm just gonna go by this template. It'll be splitter. So splitter is the library that allows you to create acapella files. It'll be separate dot I your file my time chorus dot wav has got to be a wav file -p splitter dot two stems -o splits. Split. Oh, I got to activate my. Is it music? Yeah, I got to because I have this library installed in my virtual environment, so I got to do that. All right, it's gonna take a while. Thank you, Brooklyn. Thanks for the encouragement. It usually takes me around I don't know, like depends on how complicated the project is. Like for this program, I think it'll take maybe a month to build if I do everything correctly. The videos that I've made, the machine learning dance, like the synchronization app, that took me like around let's say a month as well, a month and a half to like get everything installed and writing the synchronization algorithm. The one that took me a long guys, everyone, like it would be cool if you guys could check out that video, but I made a program that could create its own dance moves. So do you know so I wrote a program where you basically upload a bunch of different K-pop dance videos, you upload to the app, and then it creates a dancing idol, an AI idol. So I have two videos on that. So yeah, definitely check that out. That took me 2 months to make. That took a lot of brain power. Oh, yeah, but it was a fun project. It was a good project. So there's a video in my channel called Computer Dances to BTS Dynamite. So that's like the end product of that project. Yeah, highly recommend you check it out. I think it's cool. Probably the proudest project I've done so far. Yeah. And okay, oh, so now that's finished. So now here, once we've got that, we're going to outputs. Oh, wrong one. We go to splits, and we go into my time chorus, and now we have the instrumental and a cappella. And I'll turn on the desktop. I only play a little bit. I don't get copyright struck again. So, but this is what the a cappella version sounds like. Can you guys hear that? Pure acapella. So that's how you get the MR removed version of a K-pop um audio. So that's like a tutorial kinda. So let me just copy that into our AI dance thing. So I'm gonna call this my time acapella. So I have a smaller sample, might be easier for the computer to detect. Because if we use the actual track, I think some instrumentals kind of distorted the frequency detection, so it may have picked up the wrong values. So we use the acapella version just to try see if it detects the if it's more accurate that way. Yeah. Oh, you saw that program? Thank you, Brooklyn. Nice. All right. Is that? All right. Now we're gonna have to change our code in here. You now go. Yeah, for now we're still hard coding. We're still hard coding in our values, but eventually I'll fix it up so that we can like that we don't have to like type stuff into the code itself, into the source code. We can just do it through the command prompt. Let's see if this is the actual file name. Yeah, cool. All right, let's try this again. Let's actually deactivate. All right. All right, that was pretty quick. Like that wasn't even 1 second. It just creates stuff in less than a second. Yeah. Oh, 3 KB. This. Oh, wait. Let me turn up. Oh, this sounds kind of legit. This sounds kind of legit. Let's hear that again. All right, let's try a different. Let's try a different timing. Uh, Wait, let me just check if it's actual. Yeah, it's a shorter file. It's 8 seconds only. Okay. Let's try 0.1. So that's 100 milliseconds. Oh, you guys couldn't hear it? All right, let me just go back to speaker mode. All right, this should work. All right, still not quite there. Okay, so you should hear it now. Because I'm in speaker mode. Um, hmm. What do we do? What do we do? Yuju Shushi asked, what songs is supposed to be? This is supposed to be the chorus of Jungkook's My Time. You know, I can't hold up, I can't, yes, I can't sing, but that song, yeah, cool song. Um, this is much better than last week. I'm happy. This is much better than last week. Still not there. I'm still not quite there. But we're able to create some cool piano tracks. That's the thing I'm happy with. Stuff that actually sounds okay. So the output doesn't sound like the original track, but it still sounds doable. Yeah. All right. Thanks for joining, Brooklyn. Have a nice day. Bye. Okay, okay. What do we do now? Okay. The notes are correct. We just have to work the timing. Um, let's try this here again. It's 20 seconds. Why did it say? Oh, that's the number of bars. Yeah, it's 20.2 seconds. That's correct. Mm. Uh, hmm. Okay, let's just go back to this. Oh, that's way too crazy. Nah. Wait, is that actually? How can it be? Wait, why do I have? All right, that makes sense. Hmm. Let's do this. Oof. Oh, so close. We're pretty close. Pretty close. Uh, nah. Hmm. I don't know what to do at this point. I don't know how I can improve this. Thanks, Jay. Yeah, it does sound a lot better than last time. Yeah. I don't know how can we further improve it. There's got to be a way. See, there's so many different factors and variables that affect this. So here we're assuming that all the frequencies, all the pitches are correct. What if the pitches aren't correct? That's a scary thing. Oh, wait, we could test it. We can test it. Actually, let's do something that's super meta. All right, let's make this. Let's make this. All right, I have an idea. I have an idea. We're gonna take this output and we're gonna use our program to translate that output into a piano cover. Yeah. And if it works, then we know for sure that algorithm works. If it doesn't work, then we have to fix it up. Oh my god, that's big brain. This is so big brained. Haha. Let me just get this to 50. Alright, so we're gonna create a WAV. Oh, we can't import it. How can we? Ah, this is a MIDI sequence. Um, can FFmpeg convert MIDI to WAV? Yeah. Can we use FFmpeg? Let's just test it. Um, dot mid. Ah, invalid dollar. Doesn't allow for MIDI conversion. So I'm gonna have to use the online service then. No. Convert mid to WAV. Oh, this socks T raw. Wait, that's just how do you do socks file conversion command? Yeah, this one's good. Wait, do I already have in my audio processing? Wait, oh, oh, that works. That should work. Uh, convert audio to one WAV file. Okay, socks audio file path dot random temp file WAV read. Temp file. Okay, let's try that. Socks audio file name is output dot mid dash c1 dash r 16k dot b 16g temp file. Let's call this output dot wav. Oh, no handler for file extension mid. Oh, that sucks. That's a shame. Let's just use the online service. Let's just use the online service. Mid to WAV converter. Oh. This is like when you're desperate, you have to use an online converter. Yeah, this should be safe to use. Add files. Alright. Oh, now. Do I have to sign up for this? Please don't make me sign up. I just want to test my program, please. Please be kind. Please be kind to me. Oh no, it's redirecting me. Converting. Yes, download. Yeah, I'd have to sign up. Woo! Alright, cool. 29 megs for that? Dang. It's crazy. It's crazy. Not even song. Why is it 29 megs? Not even not even full songs take up 29 megs, right? It's crazy. Oh wait, they do take up a big file. Oh, MP3 is small, but WAV is big. Okay, WAVs are big. WAVs are like 8 times bigger than normal. That's crazy. Good to know. Alright, so it's downloading. So yeah, do you guys have any questions for me? Um, yeah, WAV files take a lot of space. They're thick. They're thick files. WAV files are like the big gym bros who have like huge lats and can't fit through doorways. They're big, but they can do anything. Like most programming libraries, like audio processing libraries, could only work with WAV files. So they're versatile, they're useful, but they're huge. Yeah. What's everyone's who's everyone's favorite bias? Like what's your who's your favorite bias, your ultimate bias? Just comment in the live chat, yeah? Yeah, it's gonna take 9 minutes. Why is it so slow? Oh, probably because I'm live streaming as well. That's why it's gonna take a long time. Oh, well, we'll wait for that to happen. Let's just back that code. Um, okay. Um, I think in theory this is correct. Like, got all we needed. We got all this sorted out. Just working out the duration. Yeah. Oh, but some value. All right, so let's just do this. So if let's just add in if length of mg is greater than 9, what happens? You need to break it up. You need to break this up. 17 correct. Real life Namdo-san here. Oh, thank you. Oh, that's a big compliment to me then. Like Namdo-san, his character, he's a coding math genius. I'm definitely not at that level. He's a pure genius. This one I just spent a lot of time on this. That's why. Yeah. To join the big titty gang. What? Okay. Alright, guys. Team Hanjipion or Team Dosan? I know the show's over, but everyone know. I think many people already know the end outcome. But which team do you belong? Alright, if length is greater than 9, then that's the length of Oh no, we need it greater than 36. Actually, let's see how many of them are greater than 36. Hello, guten Tag. Let's just do that. Let's just see how many lengths are greater than 36. Oh wait, should I? Oh, cool, we got this is now downloaded. Yay! Da 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 da. Okay. Alright, let's actually test. Let's test our output back into our thing. We're gonna feed our program its own output. This will be very interesting. Let's see what output it creates. Whoa, that's big. Oh, okay. So we have some. So there are some groups which are greater than 36, like this one. A lot of 52s. Okay, okay. So we have some that have that. Okay. All right. Let's actually listen to the output. So this is our actual output. This is our input. All right. Let's just hear it. All right. It sounds very different to our. Oh, it's kind of similar. It's similar. Hmm. 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 All right. Let's actually compare all. Okay. This. Let's just rename this to input. Test input. So this test input was the result of my time a cappella. So let's record the values of that. Let's, so let's get the MIDI values of that and see if the MIDI values are the same. All right. Let's just create a just save this somewhere. Just save it down there. I got this. So that's our input. That's the input. And let's get the output now. It's called input now. Oh no. Yeah. What is this? Do we randomly call one of the functions? What? Oh, called test input, sorry. Test input. Wow. Alright. This should be the same as. Whoa, why there's so many more values? Oh, this is not right. This is not right. Why are there so many extra values? Why are there so many extra values here? This is not right. Alright, the yin algo is flawed. It's flawed. Oh, it's way too big. Oh my goodness. See, it's way too many values. There's something wrong with this. Okay, that's our problem. That's our problem. The frequency detection is not accurate because, dang. Hmm. Actually, wait a minute. That's a test input. That's test input. Um, this is hard. Right. Let's try this. Right. How is this 2 minutes long? That's crazy. What? That's 2 minutes. Oh wait, 2 minute 50. That's correct. 2 minute 52. This one is also this one. Mm, wait, okay, I can just test it here. 2 minute 52 was the input. Output is 172. Right, okay, that's interesting. Oh, that's because we're using a base 2.25, right? So we're using a base MIDI, okay. Hmm, right. I've at this point, I'm not sure what to do at this point, but I feel like we made pretty good progress today. Like compared to last week, our outputs sound cleaner and they sound more legitimate, even though they don't sound that close yet to the original input. So I feel like we can call it quits today. Yeah, and I've already been coding for 2.5 hours now, so I think it's a good time to end it here. But yeah, thanks for watching, everyone. I appreciate it as always. It's always nice to see you all join the chat and just have fun and just watch. So yeah, appreciate it. Thank you, and I'll see you next time. Yeah, bye. Bye bye.